आपने शेयरशिप करने का थोड़ा मंथली ना। हाँ ये है कि हाँ
So we can start now, I guess. So yeah, hello everyone. My name is Neeraj Vishwakarma, and I'm from Kolkata, and I'm a game developer. So I guess today I'm going to interact with the students of Ajinkya DY Patil University, right? So this is from Pune, Maharashtra. Okay, and yeah, I'll be thankful to iNurture for arranging this webinar. Uh, so yeah, let's start. Let me share my screen. So you guys can see my screen. You can write in chat box. Okay, perfect. Thank you. Okay. So yeah, as we all know, this webinar is all about game optimization, and we will first discuss about what is the game optimization and why we would need this, and when to start working on this while working on the gaming projects, and of course the different techniques of the game optimizations that can be applied to, I mean, any game engine is irrespective of what game engine you are currently, I mean, focusing or interested towards. So this is the kind of common game optimization techniques that can be applied to everywhere. Okay, before starting this session, may I know if somebody is already using any kind of game engine, or try to learn game development on their, I mean, themselves? Anybody? Okay. So
Hi,
yeah,
sir.
Yeah.
We have students here from completely gaming backgrounds, sir. They are
Okay.
undergoing their game Unity game engine in all their semesters actually. There
Okay.
are from semester two, this they have started the game engine program, and they
Uh,
have semester four students who have already working on this game optimization and game asset management and a lot of other things also, sir. This is broadly about our students.
Perfect. Okay. So you mean there is already the course related to game development that you have enrolled already. So somebody is also trying to learn Unreal. So yes, Unreal is also a fantastic game engine. So Unity and Unreal, I guess these two are the top two game engines. Everybody is trying to taking grip at. So yeah, okay, let's start. Okay, once again about me. This is Neeraj Vishwakarma. I am from Kolkata. So currently, I'm working as a senior game developer with Games to Win Private Limited, which is the Mumbai-based gaming firm. Uh, you can contact me in my LinkedIn and email as well. Anytime, I'll be happy to help. Anytime. Okay. First of all, the intro. What is actually the game optimizations? As you're already learning Unity, so you must have implemented so many assets into your game. Different kind of 3D models, different kind of particle effects, different kind of audios, and every kind of thing. You are bundling it into Unity and making games, but before releasing the same there is one very important thing, and that is the game optimization that should be taken into account. So game optimization means improving the game application so it runs at the smooth frame rate across a wide range of hardware specs. Now, a wide range of hardware specs means the game can be made targeted to run on mobile devices or gaming consoles like PlayStation, Xbox, or normal PCs. So the developer has to take care about everything related to, I mean, the target hardware. Now, when it comes to mobile platform, there are two mobile operating systems, Android and iOS. iOS obviously they have upper hand when it comes to the hardware specs because they have high-end configurations. But when we come to Android, Android has low-end configuration phones, mid configuration phones, high-end configuration phones, and the developer has to take care about everything so the game runs properly on every mobile devices. So in this discussion we will discuss about some common game optimization techniques irrespective of what game engines you are using. So this is common to everything. Well, why do we care about the game optimization? Of course, the answer should be that like to serve the users with better gameplay experience and to avoid the complaints like this you can see in the right box. So yes, when we play games, sometimes in our say in our mobile devices, we can see sometimes games are crashing, sometimes frame rates are not smooth, sometimes it is causing hang to the entire system, and we have to reboot our phone. And sometimes it is taking too much space in our phone after installing the same. So these are some common issues faced by end users like the players, and the developer has to uh, uh, like take actions to solve these kind of issues beforehand before making the game published. All these checks should be I mean done. So there are tons of devices as we have discussed already in the market, uh, and we have to very cautious about while doing testing I mean to cross check on every kind of devices. So to get the confirmation that the game is good to go in the Play Store or App Store and any store in the market. Well, what is happening under the hood? Well, actually, when we talk about how the devices runs our game, so obviously so there are two important components, the CPU and GPU, who are working I mean together to make our game come alive on the screen. Okay, the CPU is the responsibility of the CPU, of course, to get the player inputs, do the every kind of mathematical calculations, every kind of physics-related tasks, and as well as the responsibility of the CPU is to send instructions to the GPU. I'm sorry, in the second paragraph there should be GPU. Mistakenly, I have written as CPU again. So, oh, sorry, no, it's okay. CPU send instructions, right? So CPU, the responsibility of the CPU to send instructions to the GPU to draw the frames on the screen. So now GPU is a special kind of processing units whose responsibility is to only work to process graphics related tasks, and every other task has to be done by CPU. So CPU and the GPU working together to bring the game on the screen with the optimal frames per second. Now, what is frames per second? To run the game smoothly on mobile devices or any playing gaming console, there should be an optimal frame per second happen. Otherwise, we will see different kinds of hiccups or jerky in gameplay. So the target frame rate that we should go for the mobiles are 30 frames per second, and for PCs and consoles it can be 60 or more than that, depending on the capability of the hardware. So you can see on the right picture the CPUs and instructions what needs to be drawn, and further the instructions taken by GPU to draw whatever has been in the instruction box. Well, so we all know that CPU comes with 4 or 6 or 10 cores. So nowadays we can see the 8 cores are very common. 10 cores are also coming. So these multi-cores are capable of doing parallel tasks related to mathematical calculations or anything apart from the graphics related tasks. Now, when it comes to GPU, the GPU can have thousands of cores because the responsibility of the GPU is too much high. I mean, uh, GPU has to take about that how many what I mean how many models needs to be drawn on the screen, how many lighting calculations needs to be done, what kind of surface properties of each objects have. So everything GPU has to calculate and render at least 30 frames per second or 60 frames per second. So you can understand how powerful GPU is. So it can calculate so many things in single frames, 30 or more than that, 30 times. So, but still, even after that we face sometimes uh, graphics, I mean sometimes problems with our games. It's not working proper, the games are freezing, crashing, and too many complaints from users. And so it becomes the responsibility of the game developer to go through every possible checks and every possible best practices to related to game optimizations. Now there are some common game optimization techniques you can see on the left side, and like reducing and combining textures, using occlusion culling, batching draw calls, using levels of details, light mapping, tweaking quality settings of the game engines, and code optimizations, of course. So I will try to also show you by doing practically, so you can understand it properly. Okay, let's go ahead. Okay. The first point is reduce and combine textures. Okay. So low number of textures will put low pressure on GPU, of course. So there should be a limitations on number of textures we are going to use into the applications, and we should try to limit that as much as possible for the smooth performance of the games. Okay. Now let's take an example. We want to show a 2D animation onto the screen, and for that for that we can have of course, you know that in order to create those animations, 2D animations, classically we create uh, different frames with different animations and run them fastly, so it creates the illusion of animations. So you can see there's a uh, some frames drawn to create the illusion of the person walking. So now we can create separate images. You can see there are 1, 2, 3, 4, 5, 6, 7 images are there just to create animations for walking. Now when we are changing the textures, these are textures of course, or sprites you can say. When we are changing the sprites too fast, so the GPU has to load every time the new image from this list and draw on the screen. Like for example, on the first it has to draw load the first image and then draw onto the screen. Then it has to take the second image, load, and then draw onto the screen. The third, fourth, fifth. That means the loading is very frequent. Every time it needs to load a different image and then draw a screen. So this can lead to, of course, the performance issue, because every time the GPU is first getting busy to load something, then rendering it onto the screen, and then we get the normal play animation onto the screen. So what can be the solution for this? Instead of using separate images, what we can do to reduce the loading of the textures multiple times and reduce the pressure from GPU. Next screen. So we can merge multiple separated image into single large image known as spreadsheet. Okay, let me show you an example quickly so you can understand. Uh, sorry, my desktop is too cluttered. Okay, so these are the separate images you can see. So it creates an illusion of character walk. And instead of that, instead of having separate images, we can go for a single image with all the frames into the single image. So these are known as sprite sheets. So now what happens? So we have, you can see, merged all the images into the single uh, big image. And then what happens next time? The GPU has to load this image only one time at the start, and from the next time it only needs to extract the correct image from the already loaded image.
हम
I
लोग कहीं
mean,
भटका गए, रुक जा रहे हैं।
Lol.
ev- hello.
We request all the students to mute your mics. Sorry, sir. Please go ahead. Sir.
Yeah, sure. Okay, so as we talking about the merging multiple images into into the single image and then loading that to the GPU, and the GPU has to load only that one time, and from the next time onwards, it will just extract the proper image from that sprite sheet and show onto the screen. So what happens now? It will only perform the draw instructions. It don't have to load multiple images many times. It already cached the big image and extracting the correct image from all that big image and drawing onto the screen. So this creates a proper and smooth animation experience onto the screen. Okay. Uh, So yeah, this was related to reducing and combining textures. Uh, if you want, you can ask questions about these topics before moving on to the next one. If anybody, or you can write in chat box if you want. So we can move ahead. So after this, the next topic is using occlusion culling. Draw only what camera can see. Now consider you must have created a large scene in Unity with say a scene like city where there are multiple buildings, uh, roads, lampposts, offices, schools, some vegetations, uh, uh, kind of open world, a big world where everything is related to a city map. Now, actually, thing is that the camera renders everything onto the screen. I mean, whatever there in the scene, it renders everything. So, for example, one second, let me create a quick scene, for example, and I will show you how we can perform the occlusion culling. So, let's create a plane and fine, and put some buildings, some buildings. Okay. Uh, Car store, electronic factory, a food factory, everything what can have in a city, a home, an industrial factory. This. Let me place a smaller thing so I can show you. Okay. Okay. Scroll mostly there. Anything else? We can go for the store, university. Well, so now our camera is, let me fix camera at the middle point. Command Shift F. So basically, what happens? It is rendering everything, whatever in the scene exists. But consider one thing: if the camera is watching in this direction, the camera can see only these things, these few objects. But the background objects like these schools, factories, and these are not necessary to be rendered at all because uh, these objects are not going to be shown at the point when the camera is looking at that point, and these will be the wastage of CPU as well as the GPU's time because uh, those will be rendered unnecessarily because they are not going to be shown onto the camera view. So occlusion culling is a feature that disables drawing of objects when they are not currently seen by the camera because they are either obscured or has been hidden by something big objects or not in view at all. So this way, using occlusion culling, we can avoid drawing objects unnecessarily, loading textures for them, calculating effects of light for them, calculating effects of shadows because of them, and etc. So all these tasks can be avoided by using occlusion culling. Now, in Unity Game Engine, we can define the occlusion culling using its by first let mark them as a static because they are not going to move. Plane should be static. Avoid auto generation of light. Okay, so this is also static. Okay, so we can create the occlusion data from the unities by going to Windows and rendering and occlusion culling. If we go to bake and there are some default values already mentioned, so we have to tweak with this so to make this appropriate for our project. So first let's try with the default value what it is currently showing. So if we bake this, you can see a blue boxes has been generated, but these are way too big compared to the buildings. So we need to tweak this by reducing it by 0 to 0.5 and bake again. Okay, you can see the occlusion culling system has tried to divide the whole scene into several smaller blocks. Now these blocks will be detected by the camera when the game is running. So camera will detect all these blocks and activate whatever inside those blocks, and the rest of the blocks will hide the game objects associated with them. So let me show you when it goes to visualization. Okay, let me first save this scene 1 second, otherwise it won't be shown. So scene, we should rename this operation play. Let's click again. Okay, so this is the whole scenario, and when we go to the visualization tab, we can see whatever the camera is currently looking towards is only rendered. And if we rotate the camera, you can see the objects are enabling and disabling according to the orientation of the camera. So what is happening, it is rendering only those objects whatever it is watching, I mean the camera is watching, and hides the rest of them. So this way it will work on only those objects and textures related to them, and avoid thinking about other objects into the scene. So this is one of the best optimization techniques, especially while working on open world kind of projects, or the project where there are some scenes like big city. Uh, so occlusion culling is very helpful in that scenario. Let me save this. So in game engines, we can create the occlusion data. So when the game runs on the target platform, it can detect what to render based on what camera sees. Okay, so this was related to
राजा भूत मिलेगा आता मोती दी खेती वाला
so this was
Sorry,
occlusion.
sir. Sorry, sir.
Yeah.
Please, Mr. Bhavesh, kindly please mute yourself. Thank you, sir.
Yeah, so if you have any question or doubt, of course, a question related to occlusion culling, you can ask me before going to the next topic, or you can write in chat box if you want, or you can write it now and ask me at the end, whatever you want. Okay. Okay, the next optimization technique is batching draw calls. So, like control on number of draw calls, we will define every term related to what is draw call, what is set pass call. Okay, so first we have to define two important terms that will make us understand how the batching works and how it can be used for the better game optimization related to uh, uh, materials and textures. So first, what is draw call actually? So draw call are simple plain command from CPU to GPU to draw something on the screen with a specific set of draw properties like visual information, like what kind of material it will have, what texture it will be, and if there will be any normal map, color map, or ambient occlusion map. So these are known as the visual information which is getting stored on material, which is again a special kind of data structure that stores information related to how the surface of a particular object is going to be look alike into the game. So draw calls are simply a plain command from CPU to GPU that, hey, please draw me a chair in that corner, draw me a table in this corner, and apply this material to this, apply this materials to that. And the next is what is set pass actually. The set pass is the process of loading material like textures, normal map, and shader properties. In order to draw a chair, we have to load its textures and other related material data. So draw call sends instructions to GPU. Please draw me a chair, and set pass calls is the process of following that instruction. Load the specific texture, the material data to render that on screen. So you can see the process on your right side. So after getting the instruction from CPU, GPU first loads the mesh object as well as loads the material properties and draws something on the screen. Now this is good for one if there is one object or 100 objects or 1,000 objects. But what if the objects are still increasing? We are keep adding new asset into the scene without optimizing them properly. So it will create a further hiccup into the game because every time, along with loading the mesh, it again load the material. It has to load the textures and material data. So that is causing performance issue again, and let's see how we can solve that. Okay, in the right corner, sorry, in the left side, you can see there's a scenario before batching, before putting that optimization into place. You can see the current scenario. You can see there are around one, two, three, four different kind of textures of a missile or shell, whatever it is. So you can see in the red highlight that four different set paths are happening because as there are four different textures. So every time when the GPU has to load all four textures in order to draw all those shells onto the screen. But as they have different textures, we can do one thing. Rather than they have different smaller textures, we can merge them into a big texture. Like sprite sheet we did, we can do this in the texture, in this texture also. So we can combine them into an atlas. We call that atlas, where there are multiple textures, separated textures combined into a single image, and then only single material is responsible for drawing every shells onto the screen. So now you can see, if we combine them all the textures into one, so you can see the set files call become one, because the GPU has to load that texture only one time and no more loading. So the set pass call become one. I will try to show you more, just a second. Let me see if I can find it here, something to show you. uh, so all these are actually colored. Okay, I will try to show something by downloading it from asset store. But for the time being, let's move ahead. So batching is the process of. So now let's consider about that example of a big city. So in the big city, there can be multiple buildings, there can be lampposts and several assets on the road. So what we can do, rather than having single textures for each building, we can combine all the textures into one big texture and use only single material to assign to every object into the scene, every building object into the scene. So this way, what happens, if there are 10 different buildings in the scene, uh, and if they are having 10 different textures with different materials, then set pass call becomes 10, because the GPU has to load, every time GPU has to load new texture to draw new building. But now, with the help of batching, if we combine all those 10 textures into one big texture, and using one material, if we draw them, then using one texture, one time loading, it will draw all the 10 buildings into the scene. So what happens here, that multiple times loading and then going to draw, it avoids that scenario, and only focus on drawing objects with a single time loaded material data. So this way batching can help us. This way, uh, we have to define during, uh, when we design the labels, or when we create the assets for the labels. During that time, we have to define that we are going to create a single image, the single texture for all the buildings. We have to create single textures for all the assets, like lampposts or post box or dustbins. All these textures related to these things will go into another big texture, and then all vegetation related texture will go to one big texture again. So this way we can categorize them and make into a single texture. So this is the way the batching works. So Unity, when we provide such kind of setup to Unity, so Unity does it using the static batching, and it really helps us to improve the gameplay performance during, especially when there are too many objects into the scene. So this was related to batching draw calls. So these two terms are very important: draw call and set pass calls. Yeah. So before starting this one, if anybody has questions related to batching or draw calls or set pass calls. Okay. Okay. So moving towards another very important thing, which is into the gaming industry since very long time, using loads or LODs, levels of details. So show level of quality depending on the distance from camera. If you have played old NFS games, so you must have seen the props which are placed into the side where the car cannot be reached is of very low quality. They can't, I mean, uh, like a paper cut, or these are looks like they are simple uh, plain paper. Because thing is that the car or the camera will never go towards that object, never come close to that objects, and thus there is no need to display those objects into the scene in with high detail, which is again to save the GPU's time, and draw only those things in high quality which is going to be interacted or come close to the camera. And so let's see how LODs can help us in this case. So what is LOD first? So LODs are basically different levels of the same 3D model which can be enabled based on the distance from the rendering camera. So now think, uh, you are playing any third person game in your mobile or maybe in your PC, and you are running towards a big there is a long road there. You can see there is something standing at the end of the road. It may be like this car you can see on the right side. So when the object is too far away from the user or from the camera which is rendering the scene, so there is no need to draw that object in high quality, as they are very far away from the camera, and it is very less likely that user is able to get that quality from that distance. So what we can do, we can create several uh, versions of that high quality model. Like you can see in the car, the original model has something around 26,000 plus polygons, and its two lower versions have 8,000 polygons, and the last version is around 3,000 polygons. So when the car is far away from the camera, we can show that load 0 to object which has 3,000 polygons, and when it starts coming towards the, I mean when the player starts going towards the car, then we can slowly upgrade the quality of the object, I mean the quality of the model. For example, when it was 100 meters away, we can show load 0 to object. When it comes around 50 meters away, we can show the load 01, which is around 9,000 polygons. And when it comes really near to that car, around 10 meters or even closer than that, then we will show the high quality model. So this way, we avoid the extra vertex calculations that has to be done by the GPU, and show the models in very low quality when they are very far away, and only focus whatever is near to the uh, player or camera. So this way, we can reduce the calculations. So same thing is related to that box also. It has four different versions and it can be activated depending on the distance from camera. So this is related to a character. So for example, you are playing a third person game, a character is running towards your side from a very far distance. So when it was very far, we can create the low poly model, which is load 3. On the right hand side you can see this one. When it come more closer, we will show load 2. When it come more closer, we will show load 1. And at last we will show the highest polygon model, and this way we will achieve good performance using the LODs into the game. Some more example, you can see that if this car is way too far, so we can draw it using just 15K triangles or just 15K polygons rather than using all the 480,000 polygons, which is the waste of GPU time. Again, more examples. So this was LODs that can help us to improve the gameplay performance this way. Okay. The next technique is actually the light mapping. Light mapping. You must have used a different kind of lights in your Unity game engine. Unity game scenes like directional light, point light, area light. So they have different purpose, and we use them. But when it comes to mobiles, especially for mobiles, we try to avoid using the real-time lights into the scene, because what happens when we use different types of lights into the scene, uh, so there are different sources of light into the scene. The GPU has to calculate that how these sources affecting the other game objects into the scene. Then it has to calculate where the shadows should be created, how much the surface has to be illuminated. So you can think that along with creating the meshes, along with loading textures uh, and drawing them onto the screen, it also has to calculate the lights and shadows, which is again going 30 times per second, is very a cumbersome task. But still, GPUs tries to do that, and as a developer, we have to make it as much optimized as much possible. So let's talk about light mapping, making light over calculating lights in every frame. So what is light mapping? So light mapping is the process of pre-calculating the brightness of the surface in the scene. So light maps allows you to add global illumination, shadows, ambient occlusions, and these all can be done in Unity Editor. These pre-computed data can be further used by the target device to show the correct light data into the scene without calculating it in every frame. So you can understand that it got data in the first hand when it loads the scene, and use the same data again and again in each frame. So this way GPU avoids the task of calculating lights in every frame. So let me show you by doing this in Unity scene. Okay, let's take this for example. So you can see the shadows are there, and it is affecting the other objects also. Let me make this affect this one. Oh, sorry, this one. So apart from putting shadows on the ground, some buildings can also affect other objects into the scene, like the shadow of this is affecting this object. So these kind of calculations are very, costly to do it in using real-time light, and this must be avoided I mean, if possible. So let's bake this. So in order to bake this, we can mark them all as a static. I guess I have already marked them static. Yes, we can mark them static. And yeah, you can see there is a directional light that will be used as a source for light mapping process. Okay, so what is the occlusion color? So we will go to lighting. So here you can see the sky. It is asking for skybox material. We will keep as default skybox. Source is skybox. We can also provide color if we want. And of course, for lights, we need to mark it as baked. Currently, it is the mode is real time. We should mark it as baked. We can increase the intensity uh, depending on the need. And yeah, let's go to the lighting tab. Let's take let's everything to be default as it is mentioned. We don't need fog, so we have removed the fog. So yeah, let's create let's generate the lighting map. Okay. So if your scene is large, so it may take a lot of time. My scene is really small, so it might take hardly 1 minute or less than that. But if scene is really large and there are too many objects into the scene, so it will take definitely much time compared to this. So after this process, once the light mapping data is done, we can remove the directional light from the scene, and still the lighting information will be there like this. So that's the power of light mapping. So I have used only directional light, but if you want, you can make use of point lights also, and mark them as baked in the mode. And when you complete the light mapping task, you can see the effects of points light have will also be there even after removing that. So this is almost done. Okay, 4, 3, 2, 1, go. Okay. So we will see the name of this is occlusion culling. So if you go to the occlusion culling folder, you can see it has created the light map data. So this is the light information it has created for this current scene. This pre-computational data has been used by the devices and whatever target device the game is running. So let's see. Even after disabling the directional light, I can still see the shadows are there. Even uh, okay. So if we remove this any object, you can see uh, it has been imposed at that place. See, it has been imposed onto the scene, and as these are expected to be static, so so we got our effect whatever we wanted. So there are too many. I mean, there are several parameters that we can tweak to get the desired effect into the quality of the light map data. So there are different light mapping techniques. And one is NLaten, which is the new one, progressive CPU we have used. and yeah, we can make use of color also. Like we can give this a blue tint. Of course, we have to bake it again. So we'll click on generate lighting again. Oh, sorry. Let me enable the directional light. Let me clear this data that we have baked. Let's bake it again. So it will provide a blue tint now because we have selected the source as a color rather than a skybox. So it is going to take around 1 minute more. Okay, meanwhile, it is complete. Right. Done. Remove the directional light, and still you can see there is a blue tint effect into the scene. Shadows have been generated. So yeah, this way, using the different parameters into the lighting settings, you can create a custom light map data, and these light maps will be stored under the folder with the same name of the scene. Okay. Okay. The same thing, advantage of light maps, as they are pre-calculated, they don't have to be calculated at runtime, and GPU has to use that pre-calculated data to illuminate the surface of the different objects into the scene. One thing, let me tell you one thing. Even when we create the light map data, we should be cautious about the size of the object into the scene. Now think about a post box and a skyscraper building. So the effect of the light mapping should be proper and appropriate on the building, because this has a big size and it will be get into focus very easily. But we don't have to be very, I mean, cautious about the small post box. We don't have to put too much calculations while generating the light map data for the smaller object into the scene. So what we can do, if you can see, when I select different objects into the right panel under the mesh renderer, you can see the scale in light map option. I mean, the scale defines how much important this object is in the scene. So if this is a big building or something really big, so we should keep it at 1. But if this is really something very small thing, something like this is not very small, but just for example, we can reduce it to something like 0.25 or something like that. So what it happens, actually it affects the resolution of the light map we are creating. This thing, from the when we do when we decrease the scale of the light map for a smaller object and recreate the same scene, I mean recreate the light map data for the same scene, the next time you can see the size of this will be much smaller. I mean, size in MBs or in KBs of the new light map data will be much smaller. So this is it, another optimization under the light mapping. So we should be cautious about that, and this will like obviously help us to reduce the memory consumption by the light mapping data. Yeah, so this was all about the light mapping and its advantages. More examples of the light maps. So these kind of effects can easily be done without using actual lighting into the scene. You can see there they must have used some kind of point light and one more light, one light either, and a very light directional light is there. So after baking, we can get these kind of effects, and we can remove the actual lights from the scene, and these effects will be there. So yeah, anything related to this? Let me check in chat box. Is somebody written something? No. Okay. Actually, we just catch up with engine. I just trying to understand. Of course. I mean, uh, if you're talking about Unity, Unity has really a good learning curve, not very steep. Um, Unreal has it takes a little time to understand its how it works, and of course, it is really rewarding if you can learn Unreal also. But Unity and Unreal, I mean, Unity is best if you are going to develop mobile-based uh, games. But now, and Unreal is famous for its rendering capability, high quality rendering capability for PC or you can say console based game engines. Um, but now Unity is also catching up with the new rendering HDRP pipeline. Unity is now targeting those gaming consoles with higher rendering quality. So any engine you take, uh, for mobile, Unity will be better. And if you are doing both, of course, Unity. If you are going to make PC or gaming console-based projects, you can of course go with Unreal. But both are fantastic game engine. And of course, the community of Unity I've seen is way much active. Uh, if you want to get any kind of answer, you can put your question into Unity answers, and probably you will get the answers very soon. And I did not dig much deeper into the Unreal game engine, but of course they have also the community is there. Okay, so let's move ahead. Well, well, okay. So tweaking quality settings, whatever game engine you are using, uh, Unity or Unreal, they must have some kind of quality settings panel where you can set the quality of the game based on where you want to run that game. If you want to run, you can see this is a snapshot from Unity. There can be multiple quality settings like very low and low for the really low end devices. You can say low end Android devices, medium and high for obviously for high end Android and iOS devices, and very high you can target for PCs, and ultra you can target for gaming consoles. So it all depends on which platform you're going to run the game. So now this is also possible that you have created a single game that you want to run on multiple platforms. You want to run it for mobile, you want to run it for PCs, you want it to run for gaming consoles like Xbox and PS. So what you can do, you don't have to do much about that. Only you can create different quality settings, and you can assign that quality settings. Let me show you by doing in Unity. Okay, so if I go to edit project settings, uh, so here you can see for Android and iOS, uh, we can select for Android we can select medium. Okay, for iOS, as it has little higher capability, we can go for high. So you can see the green mark is actually indicating on which quality it will run on Android, on which quality this will run on iOS, on which quality this will run on PCs or Mac or Linux. So we can change it to very high for PCs. So this way we can set and create different builds for those platforms. Even through coding, you can take control of the quality settings in runtime, like what what we actually do in our games. We actually write small snippet of the code to detect the quality of the hardware of the target device the game is running. If the game has a higher number of cores in the CPU, and the GPU is the new one or the latest one, we can through code we can change the quality of the game to high. Or if we detect the device is way too old and it is running low end OS, we can through code switch it to the lower quality version so it run properly. So this way we detect first the what kind of hardware architecture the game is running on, and we can then switch between the available quality settings that we have created. So this is another way of optimizations for the target platform. So you can see there are too many uh, parameters, like in rendering. If you want to show the textures in very high quality, or if you want to degrade it to half resolution or quarter resolution or really smaller one to the eighth resolution, uh, anisotropic texture, anti-aliasing. Uh, if you know, aliasing effect is when we see the edges of the object jagged. That is known as the aliasing effect. This happens sometimes, and in order to avoid that, we use the anti-aliasing effect but this definitely comes with a cost of extra calculation, and we should be very cautious while selecting what should be there. So for mobile devices, we basically go for 2x for Android and 4x for iOS devices. Of course, the latest hardwares, and for the of course the low end ones, we keep it disabled. And then, like, uh, what kind of shadow you want to show, you can define over here that I want to disable the shadow from the entire game, or we have to show only the hard shadows into the game. Because if you see, the soft shadows needs more calculations, that how much, opacity should be there in that hard, soft shadows. Hard shadows, known that there will be complete black thing. So hard shadows takes less calculation compared to the soft shadows. So we should be cautious again to select the proper listing from here. Then what should be the shadow resolution? It can again be selected depending on the target hardware device. And yeah, rest can be set as default. It will work by default properly. So this was related to tweaking the quality settings, and with the same game binary file with different quality settings, we can target it for mobile, PC, and gaming consoles. Okay, now comes the code optimization. Optimization is incomplete without doing it into the code also, because this really depends on what kind of code we are writing. Are we using any kind of game design patterns into while writing the code? Because let me show you some good practices of code optimizations. So, in order to write, optimize, and clean codes, we can use, of course, we should use the game design patterns. Um, you must have heard some software design patterns. For game design patterns, there are few patterns I can suggest. Like first one is singleton pattern, and then flyweight patterns, and then observer patterns. And so you have to, understand these patterns by going through them, and what they are actually, each pattern suggests uh, uh, different path to achieve this. But uh, the scope of every pattern is to get the game running with minimum memory consumption and maximum flexibility. So we can use different game design patterns. I will share a good website where you can learn about the different game design patterns and make use of that. And then of course, using best use of data structures to store and manipulate data. Data structures are really important to implement, understand and implement into the game. Because in data structure, if you see, there are almost uh, uh, every kind of storage and manipulations, functions have been included, and that we can use without writing our own from custom if they are not required. And of course, they will perform really good as they are battle tested, and it will help our code to remain clutter free. Use data caching if they are going to be used frequently. Now think about a situation. Uh, you must have used uh, box collider trigger. Like if the car, let's say there is a road and there is a finishing point, a car is coming, and if it crosses that finishing point, there should be some kind of celebration of particle effects coming from that point. So how we can do that? We can create a box collider, mark it as trigger, and when this trigger detects the entry of the car object, uh, then uh, let me add something more. Yeah, say after when it touches the trigger collider, the car should be stopped, or yeah, no, let me make it more real. What can be better solution? uh, mm, rigid body. Okay, yeah. Just have a funny. Just got an example of funny example. Say we have created a funny racing game, and there are multiple milestones before reaching the final point, and each milestones are actually a box collider, and they have marked as trigger. So what our requirement is, whenever it reaches a particular milestone and touches that, the card should jump, a funny effect. So in order to make the car jump, we should have the rigid body component, which is related to physics calculations. So when it touches the trigger, through code we can access the rigid body component attached with the car, and then using the rigid body we can create an upper force to the car, so it creates a jump effect. But now one thing, just consider one thing: in every milestone, whenever it touching the box collider trigger, it is always trying to access the rigid body component attached with the car object. So every time it generates a request to find the component, rigid body component with the car. So if there are 100 milestones before reaching to the final point, it has to find 100 times the rigid body component attached with the car. But we can avoid this, because finding a particular component is again a very costly task. So what we can do, when the game starts, we can get the component in the start function. There is a function start. I mean, if you must have written few scripts in Unity, then you know the start function is there, that runs when first time, only one time, when the game object gets enabled. So we can during that time, in the start function, we can get that rigid body component of the car and assign it to a variable wherever we want. So from the next time, when it touches uh, the box collider trigger at the milestones, it don't have to again find where is the rigid body attached with that car. It already has the rigid body component stored in a variable that it has done in the start function, and then just use that variable and do like jumping or anything you want. So this way, instead of having 100 searches, we will have only one search, save it to cache or save it to variable, and use it whenever you want. So through, I mean, this way we use data caching if they are going to be used frequently. Of course, the next thing is object pooling. Now consider one thing. Uh, Say you are playing a shooter game, and when you shoot through a gun, it creates a bullet, and bullet moves forward multiple times. So one way is to, when the player hits the trigger, instantiate the bullets in front of gun, and then move it forward at the high speed. So see what is happening over here. Every time we are shooting the gun, we are actually instantiating a bullet, and which is actually taking memory space in our device. So if we have fired hundreds of bullets, so it actually take 100 times the different memory spaces in our device, and that too when the game is actually running. So this can create a little problem because if you have less memory available and you are playing the game, so what the application will do, it will first try to find, okay, where I can find space to save the information of the new bullet which is going to be instantiated. So this may again create some jerky effect in the game when the RAM is going out of memory. So in order to avoid that, we can use the concept of object pooling, like in advance when the scene loaded, we can create 20 different bullets and hide them I mean, initially we will get 20 bullets and hide them, and when the user tries to fire the gun, we will just enable one of the bullets from the disabled ones and use at that point, and disable again and put it to disable list again. So this way, what is happening? We are not allocating new space, or we are not instantiating them. We are using only the bullets which has already been instantiated, and enabling and disabling based on the requirement. So this way, object pooling can help us to reduce the consumption of memory during the when the game is running, and of course, provide us good game performance. Physics related thing, if you know, if you are working on Unity, of course in Unreal there should be something, but I'm not aware of the Unreal engine. So in Unity, if you see, there are event update and fixed update. So update functions are actually runs on every frame, and it really depends on the uh, hardware capability, how much FPS the hardware is giving at that moment. So if you write something physics related thing in update functions, so sometimes you will see the physics is the calculations of the physics are not proper because the FPS of the game is getting sometimes high, sometimes low. And if this is happening with the physics related calculations, then we might get some uh, weird effects related to physics into the game. So in order to avoid that, we can use we can write physics related calculations under fixed update only. Fixed update functions are actually only called at the frequent interval, and they are equal intervals like zero point 0.2 milliseconds, 0.2 milliseconds. So we are sure that physics related calculations will be done at equal intervals of time, and we will get proper physics related activities into the game. Make use of threads whenever possible. Of course, we have we have, as we have seen earlier, uh, our CPU has multiple cores. And if you know about Unity, actually it runs in main thread only. That means it is using only one core to do every calculations that CPU has to do. Uh, so what is the point of having so many cores into the in our phones? We are having 4 cores, we are having 6 cores, we are having 10 cores, when we are not utilizing the rest of the cores into the device. So we can use multi-threading. If there is something that is not dependent and can be executed in parallel, then we can use the different cores of the CPU. So this way, the actual task gets divided among different cores, and the task will be calculated more efficiently, and of course the result would be more smooth, and we don't have to, I mean, CPU don't have to wait much time to process the queue of tasks. So this way we can get better performance using the multiple cores of the device using the threading. So these are few code related optimization techniques. Of course, there are unlimited number of techniques, and this is this will vary depending on the size of the project or what kind of features we are using into the project. Now, very most important question is at which stage we should start working on game optimization. I'd say right from the scratch when the game goes into production. Maybe during 3D modeling, we can ask the 3D modeling team to create optimized number of polygons for the specific. For example, uh, if there are characters needs to be created, then we can ask our 3D team that hey, this game is going to run on mobile, so please keep the number of polygons of the character in control, something around 2000, 3000, or maximum 5000. Should not be more than that. So optimization process starts from that point also, from 3D modeling task also. Then during texturing, we can ask the texturing guy to merge all the textures of the buildings, because we want a large textures of some small. If there are 10 buildings and they have created 10 textures, uh, so we will request the texturing team to combine all the textures into one, so we can utilize the batching that we had discussed to reduce the draw calls. During UI development again, if they create different buttons, different labels, different kind of UI elements that is going to be used in the game, we can ask them to put it into single sprite, and we will use. We will that sprite will be loaded into the GPU only one time, and from that GPU will sort out what to be drawn onto the screen. Okay, I have to draw a button onto the screen. Take the button from the spreadsheet. So this way, UI development can be optimized. And then during environment creation, we can do occlusion culling, we can do light mapping, and yes, occlusion light mapping we can do. So this can be the environment can be optimized when it start getting created, and of course at the last the developer should do its part by doing code optimization. So So basically, these were the different techniques uh, of the code optimization that has to be done while we are working on the uh, games. Now, thankfully, in the company that I'm working on, and many game studios, they have already testing team in place and quality. QA team, you can say, that who test the created game on every possible hardware, uh, to test it on variety of hardware devices to check if they are running properly or not. If they are getting any kind of bottleneck, any kind of crash, any kind of frame rate related issue, they report it again back to us, and we again start working on that to find out what had caused the issue. So testing team took that responsibility if something we have missed to find out that. Okay. So any specific tools to detect what causing issues in performance? Okay, we have done everything. We have implemented every possible kind of game optimization. Still, we are getting some issues while running the game in device or in editor also. So we can make use of Unity Profiler to find out who is actually causing that issue. So if you go to Unity window, analysis and profiler. Okay. here. So you can see there are multiple segments have been defined. CPU usage, how the CPU is being used, how the rendering is done. Is there any issues happening with the rendering? How the memory has been is getting allocated, and if some point memory requirement is getting too high. So through this section we can find out uh, audio device, sorry, audio files, effect of videos if you are playing any kind of video, effect of physics related calculations. So there are many parameters we can look at, and if we run this, you will see it will start showing some profiling uh, to us. So if you can click at any point, you can get data that in main thread what is happening, what is taking more time, or which task is making the CPU wait. Sometimes CPU send instructions to the GPU that hey, draw this object into the scene, but sometimes GPU takes too much time to draw that object into the scene, and meanwhile the CPU keeps waiting. Okay, let's wait for the GPU to complete his task so that I can provide next steps to him to that. So we can also get information from here how the memory is getting consumed at different points into the game. So Unity Profiler is really a good tool to find out what is getting wrong or is there any room for improvement. Okay, so yeah, I guess we have reached to the end of the discussion. Thank you very much for bearing with me and be the part of this discussion. And you can contact me through mail or you can connect with me on LinkedIn, and I'll be happy to guide you or suggest you whatever you need. So yeah, that was the discussion related to game optimization. Now, if we have any questions, I would love to answer them. Okay, let me go through. Let me go through this chat. I guess I got something. Actually, so why shadows consumes FPS? Okay, shadows actually. Okay, one second. Well, the GPU needs to calculate if there is one building, then it also needs to calculate that if the shadow created by this building is affecting which objects into the scene. It is affecting only the floor, or it is affecting the other objects into the scene. There might be some trees just behind the let's say building. There might be some smaller house behind that building. So a GPU has to consider all these things and then uh, 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 cast the final shadow onto the screen. So that's why it takes much FPS and should be avoided. Should be avoided with soft shadows. We can go for hard shadows that are less costly compared to the soft shadows, which is the answer for the next question. Soft shadow consume FPS. It's noise to observe the minute light opacity stores the value in the floating range, of course. Hard shadow is just 0 1, of course. So no much details is to absorb minute. Yeah, thank you. So yeah, sure. If you want, you can ask more questions, or you can write whatever you want in the chat. Of course, you can contact me if you want through this channel. And, yeah, that's all from my side. Like to know more about game design pattern. Okay, sorry. Let me give you the link of. There's a very good book about that, and even even the website, this one. So if you go, you can download the PDF from here. You can read the web version for free from here. So let me share the link into the chat box. Uh, everyone, okay, there we go. Would like to know more about game design pattern. What exactly is flyweight and observer pattern? Okay, observer pattern is actually, for example, let's say there are in the game there can be multiple events can happen. For example, a player is you are acting as a player. uh, you are fighting with other enemies into the scene, and so what kind of events will be there? It can be damage event when the character gets damaged. So for example, when it get damaged, when it got hit by bullets, uh, the health bar should be reduced, right? So we can define different events into the game, and we can bind those events with different functions. For example, say the health controller, which is actually displaying the label, I mean, health of the character on the UI. Uh, it will be it will keep listening for that event. If there is some kind of event is being fired by the applications, so it will keep listening for the event damage, for example damage. And when that actually we can fire that event whenever the bullet touches the player, and at that point we can fire that event by its name, and whoever listening to that event will act accordingly. Then the health controller will got information that something, sorry, the player got the damage, and I should reduce the uh, health by one. So initially it was 10, now it is showing 9. So this way actually it is listening to the different events in the game. So it can be, multiple scripts can listen to the same event, and they can react whenever that event is got fired. So this is what known as actually the observer pattern. So in that link you can get every possible game design patterns that we use, and will yeah, we'll find. Yes, correct. Unity actions, yes, correct. That's correct. We use action. Action is better than delegate, so action is good to go with. Okay, so I guess we are already going up 40 minutes above. So yeah, I guess it's time to complete this discussion. And anybody, if they have any questions, they can contact me. I'd be happy to help them. So yeah, Sujay, over to you. I'll be here. Or Priya.
Uh, Hello, students. If you want to ask any question, you can ask.
I know that you must have too many questions, and that I really appreciate. Uh, 1 second. Hello. Yeah. Okay, students. So yeah, please shoot me mail or connect with me LinkedIn and shoot your questions. Uh, I'd love to explain them and whatever your doubts or whatever you wanted to learn. And I really found it very interesting that your university is actually doing course in game development, and that I really appreciate. So yeah, thank you so much for everybody. Thank you so much, Immersion, for this arranging this discussion. Thanks a lot. Yeah.